we have in trigonometry, that is sine, cosine, and tangent. Trigonometry is a branch of mathematics that deals with the relationship between sides of a given triangle and then the angles itself. I've said trigonometry is a branch of math that deals with the relationship between sides and the corresponding angle. Like for example, if you consider a triangle of this kind, if you consider a right angled triangle of this kind, we have this and we have that, and I call this A, and I call this B, and I call this C. Trigonometry deals with the relationship between the sides of a given triangle and the corresponding angles. In this case, if I call this angle theta, like that one, it implies that this longest side SC becomes our hypotenuse. It implies SC is called the hypotenuse. Now, where the angle is sitting is called the adjacent side, and where the angle is facing is called the opposite. I've said that if you consider a right angle triangle that is A, B, and C, where the angle is sitting is called the adjacent side, and where the angle is facing is called the opposite side. And lastly, this becomes the hypotenuse, the longest side. However, we shall look at the ratios, that is sine, cosine, and then tangents. In this case, the ratio of sine BC over AB is called sine. Like for example, if you consider this angle, I can say the ratio of AB, that is BC, over SC is the sine, is called sine of a given angle. Like for example, I can say sine of theta. Now I'm defining the ratios, sine, cos, and then tangents. How to define a sine? To define a sine of a given angle, like say sine theta, is given by the opposite sides, which becomes BC divided by the hypotenuse, which becomes over SC. Likewise, to define cosine or cos of a given angle, the cos of say angle theta is given by the adjacent sides, which will give us now AB divided by hypotenuse, which will give us now SC. Likewise, to define tangent or tan of a given angle, we have in tan of angle theta. Tan is given by the opposite side divided by the adjacent. Opposite side is going to be BC, that is BC divided by adjacent, which will give us AB in that given case. That implies we have the ratio sine, cos, and tan being defined in terms of the sides of a triangle AB and then C, whereby sine is opposite over hypotenuse. Likewise, cosine of cos, the adjacent over hypotenuse. And likewise, tangent or tan of a given angle, it's opposite over adjacent. Here in a simple formula, recall these given ratios. We have in SOHCAHTOA, that is SOH, CAH, and then TOA. This is sine, this is cosine, this is tan. To find sine of a given angle, you divide opposite over hypotenuse. Sine is opposite, that is BC divided by hypotenuse. To find cosine, you divide adjacent divided by hypotenuse. And to find tan, you divide opposite divided by the adjacent sides, respectively. However, fine. If you consider a triangle, this triangle here, we have this, we have that, and we have that. And I call this angle theta. And I call this side X, I call this side Y, and I call this R. Now in this case, to find sine theta, in this case, sine theta shall be given by, say sine is opposite over hypotenuse. Its opposite side divided by hypotenuse, giving us where the angle is facing with the opposites, which will give us a y divided by this longest side, which is the hypotenuse. Then likewise, to find the cosine of that same angle will give us cos, which is adjacent over hypotenuse, giving us adjacent side over the hypotenuse. Thus, I'll have where the angle is sitting becomes our adjacent, which will give us an x divided by our so-called r. And lastly, we have in tangent or tan of a given angle. This tan is given by opposite over adjacent. We have in opposite over the adjacent sides. Now this one will simplify to opposites. Where the angle is facing, it is a y divided by x. X where the angle is seated, or adjacent, as y divided by x. As simple as that. Our first example in trigonometry, they say consider the right angled triangle below. We have in here our right angled triangle below. It is A, B, and then C. Then they say find number 1 tan theta. Now recall, to find these ratios, sine, cos, and tan, what you'll do, find the length of all the sides. That is AB, and then BC, and then SC. Of course, AB is known. Likewise, BC is known. First define SC. To find side SC, we have what we call the Pythagoras theorem. In this case, to find side SC, you'd say this becomes our hypotenuse, which is SC. So I'd say SC squared is equal to this, is our base, equals base squared, which base is AB squared, plus this one is height, which is going to be BC squared. Meaning in this case, I would say our SC squared is equal to AB. AB is 3. 3 squared. This becomes 3 squared. 3 squared plus BC. The BC is 4 squared, giving us SC squared equals to 3 squared is 9 plus 4 squared is 16, giving us SC squared equals to 25. Take square roots on both sides. This will go with that one, giving us SC equals to root of 5. It is plus or minus 5. But in this case, this being length, take a positive one, giving us here 5. But 5 centimeters, meaning our length SC becomes 5 centimeters. But they say find tan. Now, to find tan, you go back and recall our so-called XOH and then TOA. How do you find tan? Tan of a given angle is given by opposite over adjacent. We have the opposite divided by the adjacent, giving us, of course, where the angle is pointing is the opposite sides. Where the angle is sitting is the adjacent sides. So it implies giving us 4 divided by 3. We have in 4 over 3. That implies tan theta is equal to 4 over 3. But they say this becomes our Roman number 1. Then we have Roman number 2, that is sine theta. I'll say, they say find sine theta. Of course, sine is opposite over hypotenuse. I have opposite side divided by hypotenuse, giving us opposite is where the angle is facing, it is 4 over 5. This becomes 4 divided by 5. That's sine theta equals 4 over 5. And lastly, they say find cos theta. We have in part 3, this is part 2. We have in part 3, that is cos theta. Cos is adjacent side over hypotenuse. Of course, in this case, our adjacent is AB, which is 3 divided by 5. We have in 3 over 5. Therefore, I have my cos theta is equal to 3 divided by 5. We have example 2. They said find the length indicated by x in the figure below. In this case we are having 4, we are having x, but they said find the length of this x. In this case, where the angle is facing is the opposite side, where the angle is sitting is the adjacent side. Now ask yourself, what combines opposites and adjacents? We are having Sokatoa, opposite adjacents. It is going to be a tan. Which tan of this angle here? So I would say I have tan of my angle. Which angle is 35? 35 degrees is equal to opposites. It's going to be 4 divided by an x. From here, put over 1 and cross multiply, giving us x times tan. 35 degrees is equal to 1 times 4, which is 4. From here, divide by tan, 35 degrees, over tan, 35 degrees. These cancel, giving us x equals to 4 over tan, 35 degrees, giving us x equals to, if you divide using the calculator, 4 over tan 35, I'll have 5.71 centimeters. They say find the length of x. X becomes 5.71. Our next example, they say find the values of x and y in a figure below. Find the values of x and y in a figure below. Now for this one, you find 1 at the given time. I can first of all find here the value of y first. Of course, step number 1, this y. Step number 1, look at your angle. Here is our angle. This angle is facing that side, meaning y becomes the opposite. Then, where the angle is sitting, this one becomes the adjacent side. This becomes the hypotenuse. Meaning in this case, we have in our Sokatoa, what combines opposites and hypotenuse? Opposite, hypotenuse, it becomes sine. So I would say, to find the value of y, I will use sine of this angle. So I would say that sine of angle 33.2 degrees is equal to opposite side, which is a y, over the hypotenuse, which will give us an 8. What you do, put here over 1 and you cross multiply. 1 times y becomes 1. This means that it is 8 times sine 33.2 degrees. If you use your calculator very well and you press 8 times sine 33.2, it will give us 4.4 centimeters. And secondly, they said find the value of x. To find x, ask yourself, what combines this 8 and the x? What combines hypotenuse and then the adjacent? Hypotenuse and adjacent, it becomes cos. So I would say cos of angle 33.2 degrees becomes adjacent, which is our x, divided by hypotenuse, which is our y. To find the value of x, you put here over 1 and you cross multiply, giving us x is equal to 8 times cos 33.2, giving us x is equal to, multiply that, I'll have x at 6.7. I have 6.7 centimeters. They say given that cos theta equals to this square root of 13, then they say find sine theta and tan. In this case, what you do, you first draw a right angle triangle very well. We have that and that. This one is angle theta. Of course, we say cos is adjacent side over hypotenuse side. Meaning in this case, where the angle is sitting is our adjacent. This becomes a 12. Where the angle is facing is the opposite side. It's unknown. And then this one is our hypotenuse, which will give us a 12, a 13. In this case, you'll find this so-called height by using Pythagoras theorem. Meaning, in this case, I would say my height squared plus base squared is equal to 13 squared, giving us height squared plus 144 is equal to 169. Height squared is equal to 25. H becomes 5 centimeters. Because H is 5, call this 5 centimeters. But they say 5 sine theta. So, how do you find sine theta? Sine theta is opposite side over the adjacent side. What's our opposite? Where the angle is facing? It's 5 over 13. This is 5 over 13. And lastly, find tan theta. Tan theta is equal to opposite over the adjacent side. Our opposite is what? It is 5 over adjacent, which is 12, which is 5 over 12. That's our final answer. They say given that sine phi equals 3 divided by 5, where phi is an acute angle. Take note, angles can be acute. We have in this and we have in that. This is 0, this is 90, this is 180, this is 270, this is 360. All angles that are less than 90 are called acute angles. Acute angles are angles less than 90. Then all angles between 0 and 180 are called obtuse angles. And lastly, we are having reflex angles. We are having acute angles. These are angles less than 90. Then we are having obtuse angles between 90 and 180. And lastly, reflex angles from 180 up to 360. In this case, they said given that sine phi equals 3 divided by 5, where phi is an acute angle, meaning phi is between 0 and 90 degrees. In this case, step number 1, you draw a right angle triangle like this and like that. This one is our angle phi. Put in mind, sine is opposite over hypotenuse. This one is our opposite, giving us 3. This one is hypotenuse, giving us a 5. This one is our unknown base. So you find the base by using Pythagoras theorem. So I would say base squared plus height squared is equal to hypotenuse squared. Base squared plus 9 is equal to 25. This squared equals to 16. It becomes a 4, meaning it becomes 4. When that is 4, they say find cos theta. How do you find cos theta? Find cos phi. How do you find cos phi? Cos is adjacent over hypotenuse, giving us adjacent is 4 divided by 5. This is part A. And lastly, they say part B, find sine phi plus cosine phi. How do you add those ones? Of course, our sine phi is 3 out of 5. Plus, we have cos phi. Cos phi is 4 out of 5. Our LCM is 5. 3 plus 4, giving us an answer 7 divided by 5.